You
without
have
undo.
1 minus x minus, sorry, what is the function? Tell me again.
1 minus x square minus 4x.
X square minus 4x. Okay,
Hmm.
let's take negative common. X square plus 4x minus 1. Okay,
Yes. Yes. Sir.
this becomes what? X square negative of x square plus 4x plus 4 minus 4. We are trying to complete the square. Okay, plus 4
Hmm.
minus 4 minus 1. Sorry. Okay, ma? We
Hmm.
are trying to complete the square of this one. Okay, so that's why you're adding a 4 and minus 4. So what has this become? X plus 2 whole square, right?
Hmm.
Minus minus 5. There is a complete negative here. So what does this become? This become 5 minus x plus 2 whole square. Okay.
Okay.
This entire thing is square root. Okay. Now,
Hmm.
what is our question? He would have given you a square minus x square, right?
Yes, sir.
Okay. So now what does that mean? Square root of root 5 whole square minus x plus 2 whole square. Understood?
Hmm.
So when the x plus 2 is less than root 5, this is actually positive. Okay.
Hmm.
Okay, so now I'll give you one example, one more example. This is 1 minus x square minus 4x, right? So let's say this is actually minus 1 minus x square minus 4x, or not even minus 1, so minus 5. Okay,
Huh.
okay, minus 5 minus x square minus 4x. Okay, so this becomes what? X square plus 4x plus 5, right? It
Hmm.
becomes what? X square plus 4x plus 4 plus 1. This 5 we have split to make this a perfect square. Okay. X plus 2 whole square plus 1 negative of this. Okay. So this we cannot do anything because square root of this is a positive number.
Hmm.
X plus 2 whole square minus 1. Right. This you cannot do it. You cannot do integration for this. Okay, ma?
Yes, sir. Understood.
Okay. This thing is a wrong question. This thing still works because there is some part of it which is positive. Okay. So today anyway I wanted to discuss this. Okay. Let us go back. Okay. We wanted to do these kind of things, these four, right? Okay.
Hmm.
So basically we have this one. This is how we'll do everything. Then this splits into these two kinds, which the same idea we'll use in these three remaining also. Okay, ma?
Hmm.
Understood? This
So,
one.
sir, that question itself was wrong.
No, no, question was right only.
Hmm.
This question was right only. You
Okay.
understood? This question was right. We are able to get in the form of a square minus x square. No,
Hmm.
if this question is wrong.
Okay.
Understood.
Hmm.
This question is wrong. This question is right only.
Okay, sir.
Und- Understood.
Okay,
Okay.
sir.
Probably he would have done some typing mistake or something, but otherwise, if this is the question, this is right only. Okay.
Okay, sir.
You will get this answer. Okay. Now, okay. You will get little bit more clarity when you do the complete understanding of this one. Okay.
Hmm.
Okay. So ax squared plus bx plus c. Okay. Ax plus squared plus bx plus c is always a parabola. Okay, take only the bottom part. This is always a parabola, right?
Yes, sir.
This is always a parabola which is either facing up or facing down. Agreed?
Yes, sir.
Parabola, depending on when a is greater than 0 and a is less than 0. Okay, ma?
Yes, sir.
Okay, now if it is facing upwards, okay, what do? We remember the transformations of graphs, right? This is some
Hmm.
y equals to x square, or a is positive, or ax square, or this is y equals to ax square, right?
Yes, sir.
Okay. Now, if the parabola is transferred somewhere upwards, what does that mean? You are replacing y with some, let's say 2 or 3, and you are replacing x with some x minus 3 or something. Okay. Agreed? So then
Hmm.
this becomes 3 comma 2. Agreed?
Yes, sir.
Okay, we are shifting x
The graph.
rightwards 3 times, 3 units, and upwards 2 units. So this is something like this. Okay?
Hmm.
Agreed. So if you expand this, what you will get? X square minus 6x plus 9 plus 2 equals to y. Okay? You will get something like this. Okay?
Hmm.
Agreed.
Yes, sir.
So this kind of graph is, if A is positive, will look something like this, or something like this, something like this, but it's all facing upwards. Okay? Either it might touch x-axis or it might not touch x-axis. Okay? It might be towards the left of y-axis or right of y-axis. Okay? It might touch x-axis or it might not even touch x-axis. Okay? All are these categories only, right? In all
Hmm.
these categories, your base function is y equal to x square. You do you do some transformation. This graph, there is nothing but you can always express this graph as the transformation from y equal to x square, right? Y equal to x square, you transform it to the, there is always a vertex to a parabola, right?
Yes, sir.
You will always transform this y equal to x square to some vertex. The vertex could be this, it could be this, it could be this, it could be this. There are only four ways, right? Either you tell into send into quadrant one, two, three, four, right? This
Hmm.
vertex. Okay?
Yes,
Right.
sir.
This a doesn't matter actually, because ultimately you can always multiply with a. It doesn't matter. You can, instead of y equal to x square, you can start with y equal to ax square. Okay? So
Hmm.
this a is not so important, right? Right. Or otherwise, you can always write this as x square plus b by ax plus c, a times of this, and a you can even send out of the integration also.
Yes,
Okay,
sir.
ma? So a actually doesn't matter. That's what I'm trying to say.
Hmm.
Okay. So this always some parabola. Some parabola means there's always some vertex, and this parabola is, if it is facing upwards, the you can actually take the graph of y equal to x square and do some transformation. Okay. So then you will get in the form of y minus alpha. This alpha can be positive or negative, equals to x minus beta whole square. This beta can be positive, negative, whatever. Okay, ma?
Yes, sir.
Okay. So you can always do this kind of thing. Okay, so what this means is you can always express this in the form of x minus beta whole square plus alpha. Okay,
Hmm.
y equals to. Okay, again, this alpha can be positive, negative, doesn't matter. If it is positive, then the graph will move up. If it is negative, the graph will move down. Right?
Yes, sir.
Here, y minus alpha, if alpha, y minus alpha is equal to this thing, if alpha is positive, the graph would be something here. If alpha is negative, the graph would be something here. Okay. If beta is positive, the graph is towards right side. If beta is negative, the graph is towards left side. Okay. All four varieties, depending on alpha, beta, whether both positive, both negative, you will get in this quadrant, this. Okay. You covered all four quadrants, right?
Yes, sir.
In all four quadrants, but still you are able to express this one as this square plus or minus this square. Everywhere x minus beta is always positive. Okay. So you are getting basically x minus beta whole square plus something or minus something. Agreed?
Yes, sir.
Okay. So what we have done now, this we have expressed as x minus beta whole square plus or minus a square. Okay. Depending on what, whether it is shifting up or shifting downwards. So essentially, if you do the substitution, right, x minus beta equals to t, you have converted this into x t square plus or minus some c square. Understood?
Hmm.
Okay. So this one, any function, if it is given like this, you can always convert into t square plus or minus c square. Understood?
Yes, sir.
Which is our regular formula, right? 1 by under root x square plus a square. We have done, right? 1 by x square minus a square. You have done, right? Our original 4 or 6 derivations, right? These ones.
Yes.
This one. So you have converted to this, or where is the other one? This. No.
Hmm.
You have converted to this or x square minus x square, which is negative of this thing. Okay, ma?
Hmm. Yes, sir.
Whichever function you are given, you can always convert it to x square plus or minus a square. X square plus a square, or the negative part. If you take minus outside, this becomes d by x, dx by x square minus a square. Okay? You
Yes.
do partial fractions and finish it off. Right, ma?
Yes, sir.
Okay, so basically, whichever function you are given, you can always convert into the squares, and you can directly use tan inverse or tan h inverse.
Hmm.
Okay, okay, you take this example. In this case, he has taken this. Okay, this is a parabola facing upwards. Okay,
Hmm.
he has converted this into this format. Okay,
Okay, sir.
okay, take this 4 also outside. So we are discussing now. We are concerned about x square minus this thing. A also doesn't matter. So he ultimately removed this a outside. Okay.
Okay.
He has converted this into x minus 1 whole square minus root 2 whole square. You can always convert anything, right?
Yes, sir.
As long as this is any parabola, you can always convert it. Basically, what you are doing here, what you are saying, 4x square minus 4x minus 7. Let me draw the graph of this also. 4x square minus 4x plus minus 7, no? 4x square x square minus 4x minus 7, right? This is the parabola, no? The red one, okay? Red one. What he is saying is taking this graph and then shifting half unit, right? The vertex is half units, x minus half, right? Okay?
Yes, sir.
X minus half, and then root 2 units downwards. Okay? Root 2 units downwards. Okay? Root 2 is 1.414, and then is multiplied with 4. 4 into 1.414. So that's why it's going it downwards, right? If there was no 4, it would have been here. Because there is 4, it has gone down further. Understood? We have drawn the direct figure of this one. Okay, ma? Understood. So now
Understood.
we want to integrate this thing. Okay? Now x minus this one we are taking substitution. This already we have reached in the format of x square minus a square, right? Now x minus 1 by t equals to t square minus this thing, we know this one. But the partial fractions know that, right? Or familiar, you have reached it here. Okay?
Yes, sir.
Okay. So now if this one you can always bring it to either this format or this format, depending on a square is positive or negative. Okay, you can always bring so that if a is negative, right, then bring it outside the integral. Okay, then you will convert into x square plus something plus something. Okay, if a is negative, just remove it out of the integral. Then again you will make it positive, right? And ultimately you will either convert it to this or this. Okay, understood, no? So
Yes, sir.
for example, here a is negative. What you do? You remove that a outside. Okay, again you convert it into this to this. Something minus something. Something square minus something else square. Okay, this is in the form of x square minus a square again. Okay, ma?
Sir.
X square minus a square again, partial fractions you did. Okay, so any function, any quadratic equation, you can always express as sum of two squares. Okay, any quadratic function. Okay, because that is how the shifting of graphs also works. Right? You take the base function x square and you are adding, subtracting, whatever. Okay, ma?
Okay, sir.
Okay, so this is the basic idea. See here what you have done. Here a is anyway 1, it doesn't matter. So you have expressed this as sum of this square plus this square. So if you call it t square plus uh, c square, let's say t square plus a square, then tan inverse t by a. Okay, ma? Okay, tan inverse t by a. This is what he has done. Okay, you have to be a little careful. You remember the formula, no? Tan
Yes,
inverse
sir.
t by a or 1 by a tan inverse t by a.
Yes, sir.
Okay, you will remember those formulas, no? Because I will give you small hint also. There are this one. Tan inverse t by a. Where is this? Okay, where you get 1 by u, where you get 1 by a and where you don't get 1 by a, you have to be little careful. See, in this case, you didn't get 1 by a, but in this case, you got 1 by a. Okay, in which case you
Yes.
get 1 by a, in which case you don't get 1 by a. Some people get confused. Okay, try to remember it like this. Here it is du. Okay, here this is square root of a square du. So here let's say the dimension is 1. Okay, the power of u or something. Du is also power 1 only, no? Okay, du is nothing but u1 minus u2 kind of thing. Okay, a
Yes,
square
sir.
plus a square, square root of this dimension is also 1 because we are taking square root of some square. Okay, whereas here that this dimension is 1, this dimension is actually square. Okay, here
Understood,
the
sir.
denominator has got to the power 2, numerator has got to the power 1. So that's why in the result also you are getting 1 extra in the denominator. Okay,
Okay.
understood. So because
Yes,
there's a
sir.
square root here, the dimensions are same, we are not getting anything in the denominator 1 by a, and here you are getting denominator. This is just for your simplicity. Okay, ma?
Yes, sir.
Just
Understood.
for remembering. So here this is 1 and this is 1. Here also the power is 1 higher in the denominator. That's why you are getting 1 by a. Similarly, it
Okay.
works for inverse trigonometric functions also. You just check where you got 1 by a, where you did not get 1 by a. But this applies only for the outside coefficient. Inside anyway it will always be u by a. Okay?
Understood, sir.
Inside it is always u by a. Outside whether you will get or not depends on what exactly is the dimensions of the numerator and the denominator. Okay, just
Hmm.
verify this for regular trigonometric functions also. Tan
Fine, sir.
inverse, sine inverse, etc., etc. Okay. Now you understood this. You can always express it as square sum of two squares. Okay. Right.
Yes.
Now, by the same logic, this inside of square root also you can do, right? Because it is still x square plus bx plus c, right?
Hmm.
Okay. Because inside squares you can do, then that means this one should convert into this or this. Agreed? Just like this one converted to this or this one should convert to this or this. Agreed?
Yes, sir.
Okay, so that means you know how to integrate any function like this. Because if we express this inside as sum of squares, it will get to here or here. Okay, these three only.
Fine,
Agree,
sir.
Amma? Okay, so for
Hmm.
example, you express this, you become t square plus x square, which is sine h inverse. Okay,
Yes, sir.
okay. If you express this, you take the negative one outside, and you do this. Okay, I think the video is something like this. Okay, that is in the numerator. That is fine. Okay, now we express this 5 by 4 minus something. Okay, so this is a graph that is facing downwards. Right, Mark? This is
Yes,
in the
sir.
form of dx by under root a square minus x square. A square minus t square. You know this. This is sine inverse. Okay,
Hmm.
sine inverse t by a. Okay, ma? So,
Hmm.
similarly, okay. Got it, no?
Yes, sir.
Ah. So, this one you can always express in terms of this. Okay. Now, in our syllabus, the third case is not given. Okay. But the other case is actually this one. This case is not given in JEE syllabus, but still, it is the same method. Okay. This we can always
Hmm.
express as a difference of squares of two numbers. Again, so this converts to what? This converts to this and this.
Hmm.
Okay. This
Yes,
one,
sir.
this one will convert to either of this. Okay. You will just express and you will just convert. Okay, ma?
Hmm. Fine, sir.
Okay. So basically, this converts to the simple ones. Okay. This converts to this and this converts to this and this converts, so okay, this converts to this and this. Okay, and you know all the derivations of so what that means, derivations of all these ones except this and this. Okay, you know
Hmm.
everything except this and this. Okay, now we will see about this and this. Okay, now
Fine.
when you come here, px plus q, this is a linear one. Okay,
Hmm.
ax square plus bx plus c, if you differentiate this, you will get some linear function. Okay,
Hmm.
so for example, px plus q is something like 2x plus 3. Okay, ax square plus bx plus c, let's say you get something like uh, minus 7x plus 5. Okay,
Okay.
this is a linear function. This is also a linear function if you differentiate. Okay,
Hmm.
now you can always multiply with this with something to match this 2x. Okay, so for example, you can multiply with 2 by minus 7. Okay,
Hmm.
then
Fine,
what
sir.
you will get? Then what you will get? 2x plus 5 into 2 by minus 7. Okay,
Yes, sir.
5 into minus 2 by 7. Okay, then you can always add something to match to make it become 3. Okay,
Hmm.
okay, so basically whatever this becomes minus 10 by 7, right? Minus 10 by 7 plus something should be equal to 3. So this something should be equal to 3 plus 10 by 7. Okay,
Okay, sir.
plus 3 plus 10 by 7. Okay, basically whatever you have subtracted, you have added 3 plus this one. So now what you have done, this numerator, you are able to express in terms of something into differential of denominator plus some constant. Understood?
Yes, sir.
What you have done? You have done nothing. You have did the differentiation of the denominator. Okay, and because
Hmm.
differentiation of denominator also involves one x, this numerator involves one x. First you match the coefficients of the x, and then whatever is left over, no, you adjust in the constant. Okay.
Hmm.
Okay,
Fine.
so first you adjust for the a, and then whatever is remaining, no, just like here, sum of squares we adjusted in a square, no.
Hmm.
So here you adjust in terms of b. Okay. Why we are doing this? Because now this will massively simplify this. Okay. If you do differentiation of this, no. Okay, I will show you with example. Uh, See here, you have expressed this in terms of differential a times the differential of denominator plus some constant. Basically, you differentiated this 2x plus 3. Okay, you match this 2 with this 1. Okay, so that's why you got half. Okay, and adjusted the remaining part in b. Okay, you got this one. Okay, now the numerator has become this. Agreed?
Yes, sir.
Okay, now we express this one in this form and then just split that. Okay, this becomes what? Half of 2x plus 3 by this thing minus half of this thing, half of dx by this thing. This you know directly.
Hmm.
Okay, earlier we did this. Now this one, this if you can see, if this entire thing has become t, this 2x plus 3 dx has become dt. dt by t, this is actually, right?
Hmm.
So this also you know. This becomes ln t. This anyway you know. Understood, ma?
Hmm. Yes, sir.
So f dash x by f of x, we want to get f dash x by f of x. For that we did this. Why did we express this as differential of denominator? To make this ln t. Okay, ma?
Fine, sir.
See here, logarithm of this thing minus again the regular way. This you have to do anyway. Okay, so that's why I'm
Hmm.
saying all of this will boil down to one of those basic, very basic four functions. One, this. Okay, all of this will boil to.
Hmm.
Okay, so now you know how to do this. What you have done, this you express as differential of this plus some constant. Okay, here also it's the same thing. This you express as differential of this plus some constant. What will happen? So, okay, I'll show you with an example again.
Hmm.
Okay, you express this. So basically you did differentiate 4x minus 1. This 4 and this 3 will match. So that's why you multiplied with 3 by 4 and remaining part you adjusted in b. Okay. Now
Hmm.
this becomes, you just split this and expand this one. Now you call this t, then this into dx will become dt. Okay. So t power half will become t power 3 by 2. Okay.
Hmm.
Okay, this is plain polynomial integration. After that, this again is, you can express this in the form of x square minus a square.
Hmm.
Okay, x square minus a square, which you have direct formula. Understood? Integral of
Yes.
square root of x square minus a square, you already know.
Yes, sir.
Okay, so basically what you have done, we have split this into differential of this one plus some constant, and then we broken that, we got one polynomial kind of integration, and another again your earlier one of these earlier methods. Okay, ma?
Hmm. Fine, sir.
Okay. Okay, so now you know how to do this one also. By the similar logic, and you can do this one also. Okay,
Okay.
I will show you one more example. Where is this? Okay, I think I did not put that example, but still it's the same thing. Okay, it's the same thing. Okay, so this one px plus q is a into f dash x. Okay, plus b by root of f of x, right? This means, so if you split this, what will this become? A into f dash by f plus b by root of f of x, right, ma?
Hmm.
This becomes a ln f plus b times integral of dx by again root of ax square plus bx plus c. Okay, which is nothing but, this is nothing but this format. Okay,
Hmm.
this one root
Yes.
of a square plus bx plus c, you will mention it as dx by root of something square minus something square. Okay, then you will get into one of those regular formats, one of those this or this. Okay,
Fine, sir.
understood, no? So basically
Hmm.
you know, now you know how to do all of this, right? You know how
Hmm.
to do,
Yes.
how to do all of this. So there is no doubt, this is very important, you being comfortable here, no, this is actually very
Hmm.
very important. Okay,
Okay, sir.
just do little bit of practice. The idea is to understand that the parabola can always be transformed as some other parabola plus some constant. Okay.
Fine, sir.
Okay. So another important thing. Let's say you are given something like this: ax plus b and root of px plus q. Okay, ma?
Hmm.
Okay. So here root of px plus q will take it as t. Okay. Then dt will becomes what? 1 by 2 root this thing into p. Okay.
Yes, sir.
Understood. Let's say, for example, root of x plus 4. If you take this as t, dt will become 1 by 2 under root this thing plus derivative of x plus 4, which is anyway 1, like this. So basically, why we are trying to do is we are trying to eliminate this part. Okay, dx by this thing will become 2 dt, right? So that
Hmm.
becomes 2 dt, and x plus 5. What is if t equals to root square root x plus 4, t square equals x plus 4, and x plus 5 will become t square plus 1. Okay, this you can express it as again some parabola, quadratic equation, right?
Hmm.
Understood. So now we have got into our regular format: dx by ax square plus bx plus c. Understood. So what is the square root? We have tried to remove the square root and got it in the format of dx by ax square plus bx plus c. After that, you can do in our regular fashion. Okay, ma?
Hmm.
Understood now? How we have actually converted this into our ax square plus bx plus c format?
Yes, sir.
Okay. Now, see here, this is another important one. Okay. This one is actually a special case of this one. Agreed? If
Yes, sir.
in this thing, if sin x is not there and sin x is not there, it will become this, and numerator, these two are not there, this will become this. Okay. For all of this, okay, the basic, very important substitution is this is called universal substitution. Cos theta equals to 1 minus tan square by 1 plus tan square. Sin theta equals to 2 tan theta by 2 tan x by 2 by 1 plus tan square x by 2. You remember this formula, no?
Hmm.
Okay, sin x, you can express it like this, right? Why we can
Yes,
express
sir.
like this? Sin x is nothing but 2 sin x by 2 cos x by 2, right?
Hmm.
Sin 2 theta, sin x equals to this. So we can always write this as sin square x by 2 plus cos square x by 2, right? Because we are dividing with 1, we are doing nothing. Okay, sin x we can always write like this. Agreed, ma?
Hmm. Yes, sir.
Agreed. Okay, now we divide both numerator and denominator with cos square x by 2. 2 sin x by 2 cos x by 2 by cos square x by 2. Okay, here also sin square x by 2 plus cos square x by 2, whole of this by cos square x by 2. Okay, we are doing nothing. We are just expressing it in different format. Okay, ma? Now,
Hmm.
now what will happen to the numerator? 1 cos x by 2, 1 cos x by 2 will get cancelled. Sin x by 2 by cos x by 2, that becomes 2 tan x by 2. Okay?
Yes, sir.
Okay, this one sin square by cos square will become tan square x by 2, and cos square by cos square will become 1. So basically what we are saying, 2 tan x by 2 by 1 plus tan square x by 2 is sin x. Okay?
Hmm.
Okay, so similarly cos x. Cos 2 theta is cos square theta minus sin square. So cos square theta minus sin square theta. Okay? Cos square x by 2 minus sin square x by 2. Agree, Amma?
Hmm. Yes, sir.
Okay, so this you can always divide with cos square x by 2 plus sin square x by 2. Okay, we are just dividing with 1. Now, again, divide both numerator and denominator with cos square x by 2.
Hmm.
Okay, by cos square x by 2. What will happen to the numerator? 1 minus sin square by cos square, which is tan square x by 2. Agreed? By denominator,
Yes, sir.
1 plus tan square x by 2. Okay,
Hmm.
which is what we are doing here. So this substitution is very important. Sin x and cos x, you can always substitute. Okay. Now, if you do this kind of substitution, what will happen? 1 minus tan square, b into 1 minus tan square, a into 1 plus tan square. Okay. So then the numerator 1 plus tan square will go to the numerator. Okay. 1 plus tan square is again secant square. Okay, ma? Okay, basically
Yes,
in the
sir.
numerator we have secant square x by 2 dx, and denominator we have some quadratic function in terms of tan x by 2. Okay, let me show you some example. Okay, you got some function like this. Okay, now we can always substitute tan x as t, then secant square x by 2 as dt. Agreed? If you substitute this as t, then numerator will becomes dt. So you are actually converting this into dx by ax square plus bx plus c block format. Okay, agreed?
Yes, sir.
Okay,
Hmm.
just any trigonometric, these kind of things, if we substitute, okay, if we substitute as tan x by 2, we are using 1 plus tan square. This denominator will go to the numerator. That becomes secant square. We are using that idea. Okay, if we substitute as tan x by 2 as t, then this entire thing, this or this will actually convert to dx by ax square plus bx plus c format. Okay, this is actually
Yes,
a
sir.
simplified version of x square plus bx plus c format, right? Agree, ma?
Yes, sir.
Okay, so now another special case is this. Okay, a cos x plus b sin x plus c by d cos x plus e sin x plus f. Here what we will do, here the numerator we express as some times of differential of denominator plus some other times of denominator plus some constant. Okay, agreed.
Yes, sir.
Some times of differential of denominator. Okay, plus some other times of denominator plus some constant. Okay. Okay,
Okay.
here this works. So you will be always be able to find some A, some B, some C. Okay, just
Hmm.
like earlier we were able to find some A, some B, right? In this case, some
Hmm.
A, some B. In this case, here also you will always be able to find some A, some capital A, some capital B, some capital C to express this. Okay,
Hmm.
okay. So that why you can always find out because A cos x. Let's say cos x is some uh, let's say a cos x plus b sin x, right? And d cos x plus e sin x. If you multiply with
Hmm.
something, and if you compare all the coefficients, right? Cos x coefficients and sin x coefficients. So, for example, this becomes what? Let's say the numerator is 2 cos x, 2 cos x. I'll write it in a different place. Let's say this is the denominator. Okay, you want to convert this to, let's say, 5 cos x plus 2 sin x. Okay,
Hmm.
okay, if you differentiate this, what you will get? So basically you can multiply a into 3 cos x plus 4 sin x plus b into something. What is that something? Minus 3 sin x. Okay, we are just differentiating this plus 4 cos x. Okay, ma?
Okay, sir.
Okay, plus some c. So for simplicity, let's assume cos x as x and sin x as y. Okay, what we are
Hmm.
saying, 5x plus 2y should be equal to a times of 3x plus 4y plus b times of minus 3y plus 4x, right? Some
Okay.
plus some constant, right?
Hmm.
Okay, so what does that mean? This becomes 3a plus 4b into x, agreed?
Yes, sir.
Plus 4a minus 3b times y plus some
Huh.
constant. Okay, so basically what that means, 3a plus 4b equals to 5 and 4a minus 3b equals to 2. You will always be able to find some a comma b, right?
Huh.
Because you have two equations, two unknowns. Okay, you will always be able to find some a comma b and remaining part you adjust in C. Okay.
Fine.
Okay, because he is any constant, it doesn't matter actually. So basically, what we are trying to say is this entire exercise is to say that no matter what is the numerator and denominator, if it is cos x and sin x, some combination of this thing, if this is some combination of this thing, you can always express the numerator in terms of in this format: a times denominator plus b times differential of denominator plus some random constant. Okay.
Okay, sir.
Agreed, ma? You can always express this. Now, how will it help? Same. This becomes a times f dash x by f, right? F dash x by f. This turns out to log of f of x, right? That becomes log of f of x plus b times f of x by f of x, right? This becomes 1. Okay, plus 2x. Agreed? 2 times 1, 2x. Okay, and this one you will be left out. Okay,
Hmm.
plus 5 times only the denominator part of it. But this, what you will do now, denominator part, you have your universal substitution. 1 minus tan square x by 2 by 1 plus tan square x by 2. Agreed?
Hmm.
Plus 2 tan x by 2 by 1 plus tan square x by 2. You substitute here. Okay, plus 1. So basically, the denominator will become plus 1. Okay. So this tan square x by 2, 1 plus that becomes secant square x by 2 in the denominator. You are getting it now? By 1 minus tan square plus 2 tan x by 2 plus 1 times 1 plus tan square x by 2. Okay? Okay. So if tan x by 2, you take it as t, denominator is actually a quadratic equation. And secant square x by 2 dx, you can convert it to dt. So basically what you are getting, dt by, so basically you are getting by quadratic equation, at square plus bt plus c. Okay, ma? So this you can convert into a quadratic equation. See, here he substituted, he was able to convert this because there is one, he's actually getting it slightly easier. Okay, he has got it into a quadratic equation. In fact, this is slightly easier. It didn't even come till quadratic equation. Sometimes you can get till quadratic equation. Okay, you might have got it t square also. Okay, ma, understood, no?
Hmm.
Hello.
Yes, sir.
Understood, no?
Yes, sir.
Okay, okay, very good. So now you know lot of different varieties of at least all the major points that you have in the syllabus you are covered, right?
Hmm.
Okay. So now coming to some important things in by parts. Okay, we covered this part, this part. You remember this derivation, no? We started with
Hmm.
here and this thing. Okay.
Yes.
Okay. So if you have to do by parts of this, what you will do? You will take the second function as the one where you can integrate easily. First one as the one where you will differentiate easily. Okay.
Hmm.
Okay, so now you know how to do by parts of this. First function into integral of second function minus integral of differential of first into integral of second. You remember that. Okay. Okay.
Hmm.
Sometimes it becomes little tricky to do lot of by parts because sometimes the second function also you might to do. See here, if you do
Hmm.
this, you got a second function there. You have to do by parts again. Okay. Understood. X square e power x. If you have to do the second x e power x is okay one step. Okay, but second function you have to do by parts again. Okay, sometimes you might have to do by parts within by parts. Okay, for that it becomes little easy if you follow it up this way. Okay, see here what we are doing x square e power x. Okay, we are
Hmm.
taking first function as x square, second function as e power x. Okay, we kept on doing derivatives of this function. X square becomes 2x, 2x becomes 2, this becomes 0. Agree?
Hmm.
Agree, Amma?
Hmm. Yes, sir.
Okay. This one we kept on integrating. So it doesn't change actually. Okay.
Hmm.
Now the final answer is you take first one as positive, second one negative, third one positive, fourth one negative, likewise. Okay. So what we are
Hmm.
doing? X square into e power x. This second one is negative. Minus 2x into e power x. Third one positive. Plus 2 into e power x. That's what we have done. This is the final answer. Okay. This
Hmm.
kind of depiction becomes very easy. Otherwise, you have to do by parts and by parts, and you might lose some signs and all. Okay,
Fine, sir.
understood? No.
Hmm.
So, for example, if you are given something like x cube sine power sine x, it becomes very easy now. Okay, you take the
Hmm.
first function x cube, second function sine x. If we differentiate this, this becomes 3x square. This becomes what? You have to integrate this one.
Integration of sin
Sine
x
x minus cos x, right?
minus cos x.
So
Hmm.
what you if we differentiate will become sine x. This becomes 6x, right?
Hmm.
This becomes what? Min
Differentiation of minus cos x, huh?
no, no, no. This is integration. You have to keep integrating this one. You have to keep
Oh.
differentiating this one. Okay. See g of x and its integral. What if you okay? Or what is that function? If you differentiate, you will get minus cos x. That is minus sin x.
Hmm.
You think of it that way. Okay. What is that
Hmm.
function? If you differentiate, you will get minus cos x. Okay. What if you differentiate? You will get 6. What is that function? If you differentiate, you will get minus sin x. That is cos x. Right? This is 0.
Understood.
What is that function? If you differentiate, you will get cos x. This is sin x. Okay.
Hmm.
Now, what you do? You combine this, and this. Okay. First one is with plus, second one with minus, third one with plus, fourth one with minus, fifth one with plus. Okay. 0 is anyway, doesn't matter. So, what does that mean? What is our final answer? Minus x cube cos x. Understood?
Hmm.
Okay. Minus into minus plus. Plus 3x square sin x. Understood? Again, 6 into cos x plus 6 cos x minus 6 into sin x minus 6 sin x plus some constant. Understood?
Understood.
This kind of doing things will become very easy. Okay, you keep doing differentiation, keep doing integration. This works with any kind of by parts. Okay, and
Hmm.
more so useful in this kind of setting. Okay, where if you do continuously differentiate, you will get 0, and if you continuously integrate, it more or less remains the around the same function. Okay, understood? No, see here, x cube sin x. This is what we have done. Okay, x cube, we're done differentials, and then we have reached here. Okay, ma? First one is plus, second one is minus. Minus into minus is anyway plus. Third one is plus. Fourth one is minus again. Okay, agree, ma?
Hmm. Yes,
Okay.
sir.
Okay. In some case, sometimes you want to, this might not break. Okay. Some cases, what you will do, uh, you want to express it as the same integral again. Okay. So, for example, e power 2x cos 2x. Okay. X square will break it down. X square will ultimately will become 0. But if you have two functions like e power x and cos x, they will never break down. Agree, Amma? Because how many
Understood.
times you do you do by parts, you will still get the same thing, because you'll always get in terms of e power x or cos x. In this case, what you do, you start with the same process. Okay, e power
Hmm.
2x. If you differentiate 2 e power 2x, if you differentiate this again, 4 e power 2x. Agree? This one, if
Yes,
you
sir.
integrate, you get sin x. If you integrate again, minus cos x. Okay, so you stop at a point where you get the base functions again. Okay, don't worry about the coefficients.
Hmm.
Agreed? You got cos x back, you got e power 2x back. Okay? Now, now we'll express it in the same method. Okay? E power x, this is positive, this is negative, this is positive. Okay? But while expressing the final integral, no, so what you do? E power x into sin x. Okay? Plus of e power 2x into sin x minus of 2 e power 2x into minus cos x. Okay? Minus of 2 e power 2x into minus cos x. And the final one, earlier you are going down. Okay? When this time what you will go? You will go flat and say you express this as integral. Okay? Plus into minus is minus. Okay, plus integral of 4 e power 2x minus cos x. Understood? Okay. Earlier you are going this way because we are not stopping for any integral. Okay.
Hmm.
Here you'll stop at this point when you found the same repetition. Then you express this. Okay. Now what you will do? This I you express in terms of again I. I equals to this thing minus 4i. Agree, Emma? Hello.
Hmm. Yes, sir.
Agree, no?
Yes, sir.
Okay, so 5i will become this thing, and so that's how you evaluate the integral. Okay?
Hmm.
Ah,
Sir, I'm telling yes sometimes. I guess it's not being heard.
it's not audible, I don't know. So
Oh,
okay, now you are audible. Sometimes you are
fine.
not audible. Okay, cool.
Hmm.
So, okay, tell me. So, today what we have discussed, tell me. What all we have discussed? Uh,
By
from here, tell
means,
me.
the last, after the first four, we discussed the next three
The
ones.
first four, okay. Just give me a summary. What we did for first four? I am just asking again and again so that you will never forget. Okay.
Hmm.
First
Okay,
four.
sir.
Well, okay. Just quick revision of first four also. What we did
Hmm.
for first four? X square plus a square is tan inverse
Tan
this,
inverse x by.
x by a. Here, what we did substitute x square plus a square doesn't matter. You can substitute either x equals to tan theta or sin h. It doesn't matter. Okay.
Hmm.
X square minus a square. X has to be greater than a, so it should be
Greater
secant
than.
theta or cos h. Okay,
Huh.
secant theta or cos h, you can substitute. A square minus
Hmm.
x square, this is partial fractions, log by log.
Log. Yes, sir.
Okay, under root a square minus x square, x should be less than a, so x should be sin theta. Right,
Sin
sin
theta.
inverse x by a you will get. Okay,
Yes, sir.
then again same logic for in the numerator also. But
Hmm.
numerator we did two methods. One is x is tan theta x is equal to sin h theta and sin hx sin h theta, or otherwise we did by parts also. Second function we assumed it as 1, right? This and this
This
we did
one.
in two methods.
This one will be x by 2 root a square plus x square.
Right. We did by using two methods, right? This
Hmm.
one, this is one method, okay, using by parts, and there is another method using substitution. Okay, so for example, here, this one, this is by parts method, and this is substitution method. Okay,
Hmm. Yes, sir.
the numerator part, this is one is by parts, another is substitution. This part is substitution. Okay, you can do both. Okay,
Hmm.
but ultimately you should be able to reach all those final results effortlessly.
Final
These
result.
four
Hmm.
and these two. Okay, in fact, this one will have two each. Okay, after this, what we did? What did we do here? What is the idea here?
That the coefficient doesn't matter.
Coefficient doesn't matter. Yeah, if it is negative, you can bring it outside. It is
Hmm.
it is about x square plus. It is a quadratic function. You can always
Quadratic.
express in terms
Hmm.
of sum of
Parabola.
it's a parabola, and by shifting, you can always express it as sum of two squares. Okay, either sum
Hmm.
or difference of two squares, right?
Hmm.
That means you can always get this into this or this. Okay,
Yes.
this one you can always get into this or this, right?
Hmm.
This one, what you did?
Partial.
No, this is not partial fraction. This one, this is numerator. We express this is a linear
You
function.
can't relate it to the other four.
It is related, but what we did here, px plus q. Px plus q, we express it as something into differential of denominator plus constant, right?
Hmm.
Okay, you remember this. This is a linear function. This is
Hmm.
also a linear function. We first found out A and remaining part we adjusted in B. Agree,
Yes,
Amma?
sir.
Okay.
Hmm.
So Px plus Q, what we did? We differentiated denominator, and the denominator differentiated is also a linear function. So we adjusted for P, and remaining part we adjusted for Q. Okay.
Hmm.
Understood. Then what happens? Then you got two functions f dash x by f of x, and then second one is again anyway this format.
Hmm.
Agree, Amma?
Yes, sir.
Here also what we did, px plus q in which format?
Like
Sometimes
take it into another variable and then
something into ax, something into differential of denominator plus
denominator.
some constant. Okay,
Hmm.
okay. So you remember this. Okay, this one, right? X plus one as something into differential of denominator plus some constant. Okay, this is 2x plus 3, and that's why here it is x. That's why we want a to be half. Okay, remaining part we adjusted in b. Okay.
Fine, sir.
Okay. Next, you remember this one. What we have done? This also we convert into x square plus bx plus c. What did we do here?
Take root px plus q as another variable.
Another variable, right? So this entire part will vanish. Okay. This part we can express it as again a quadratic function then. Okay. In
Hmm.
terms of the t. Okay. This part will vanish and this becomes a quadratic equation, which anyway you know how to do. Okay. 1 by quadratic equation is become very easy now. Okay. In this case, what you have done? This is actually a special case of this one. Tell me for this one what we did.
For a cos x plus b sin x,
Yeah, this one.
we wrote cos x in terms of cos square x by 2, sin square x by 2 kind.
Cos square x by 2. No, no, no. Cos 2x. This one. This be little careful here. Okay. So
Hmm.
first we have express numerator in terms of something into differential of denominator plus something else into denominator plus some constant. Okay. What is
Hmm.
the idea? Idea we have to convert everything to tan x by 2. Okay.
Okay.
Okay. So first what we have done here, express numerator in terms of something into differential of denominator plus something else into denominator plus some constant, right?
Hmm.
Agreed.
Hmm.
So whatever is the numerator, if it is whatever is the numerator, you can always express as something into something into something into denominator plus something else into differential of denominator plus some constant. You agree? Because we
Hmm.
are getting two equations and two unknowns, we can always express. Okay. So for example
Hmm.
here, okay, we express this. Then this function f dash x by f of x.
Hmm.
Okay, ma? This
Yes, sir.
becomes direct log, and these two will directly cancel because it is f by f. And you are left with this function, something like this. Okay, a simpler
Okay.
function. This one you always put sin x in terms of tan x by 2, cos x in terms of tan x by 2. Okay.
Hmm.
Okay, so here also cos x in terms of tan x by 2, sin x in terms of tan x by 2. Why we are doing this? Because then this will convert into again some quadratic equation, dx by some quadratic equation, right?
Hmm.
So the goal in all of this is actually ultimately to reach our original 4 only. These 4
Okay.
only. Okay, these ones only. Because once you reach a quadratic equation, then it becomes easy, right?
Hmm.
Understood, ma?
Yes, sir.
Okay, now we understood how to do this one also. This ultimately we are converting into a quadratic equation. Okay?
Hmm. Okay, sir.
Okay, cool. I think then we have covered most of what is given in your textbook. Okay.
Hmm.
There are some reduction formulas also, which I will tell you. Okay, so for example, I think you are not given that in your textbook. So for example, sine power n, cos power n,
I know, sir.
sine power,
I know formula, I know.
where are those? I didn't see them.
Like in that video which I told you that I saw,
Ah, 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 ah.
he was solving based on that. I know formula for sine square theta, cos square theta, and tan square theta.
No, not square, sine power n. What if we are given sine power 6?
It's like 1 minus cos n theta by n.
That's what. How exactly did we get this? Because
That
formulas.
derivation only.
Right, right. Because
Hmm.
formulas, now you will remember, but in exam, in the tension, you will forget.
Hmm.
Okay, so that's why it's better because that is basic by parts only. Okay,
Hmm.
so let us do that once so that you will remember it. You will not forget the formula. Okay, because you have too many formulas. No, every chapter you will have a lot of formulas. Otherwise, you have to
Hmm.
remember physics, chemistry also.
Yes,
Okay,
sir.
so you should ideally try to reduce the burden of remembering. Okay.
Hmm.
Logically deriving will become slightly easy sometimes. Okay, it's easier, it's good to remember, but it's better to know the derivation also. In case you forget, it will help you. Okay, so that is one thing. And before that, we have to cover partial fractions. Okay,
Okay,
partial
sir.
fractions is there in our syllabus. I think then you can do all of these questions, right? At least in your textbook, we have covered everything.
Hmm.
This part we have covered everything. What we are trying to do is we are trying to go little advanced than what it is required here. Okay, but this entire chapter you can do, I think, the integration part.
Except for reduction, then
Reduction is not there, no. In your book, reduction is not there, I think.
but sir, like that video was just uploaded yesterday itself.
Which video is this?
Simplified Minds one for 5 markers, 2025 PUC board exam.
Oh, okay, okay, okay. But it is not there in. Is it there in our syllabus? Reduction.
Yes, sir.
Sign. It is there.
I don't know why NCRT didn't give. Because this is also CBSE board book, right?
Oh, okay, okay. Then anyway, we'll do it. Reduction is actually very easy. It's not so difficult. Okay.
Hmm.
Reduction is very easy. Okay. What else you have? You have functions. Functions in second year only.
Hmm.
Inverse trigonometry, matrices.
Sir, it's there in first year also.
Okay, okay, okay. Got it, got it. And what is there in the other part? Part two. This is part one, huh?
Hmm.
What is there in part two?
Sir, now what you're seeing it is part 2 only. Part 1 they gave like simple summary what is there.
Oh, okay, okay, okay. Got it, got it. This is okay. These are there in part one. Okay, and
Hmm.
integration is there in part two. Okay, integration, differential equations, vectors are also there. 3D is there. Probability is there. What all you have finished?
From part 1 and part 2 combined, sir.
Yes, yes. For boards, what all you have finished?
I did probability.
This is done. Very good.
LPP I didn't do still. I
Okay.
should do today, sir.
But you
And then
know how to
3D.
do.
Hmm, sir?
You know how to do. No, there is no
Ah, yes,
confusion.
sir. I just need one last time revision.
Ah, okay. This one you know how to do. No,
Done. 3D geometry done.
you don't need any help here, right?
No, no, sir.
Okay. Very good. This one.
I need to do today.
Okay, but you can do no this,
Hmm.
or you need any help. You don't.
No, sir. Today I'll do it. If I have any doubt, I'll ask you, sir.
Ah, okay, okay. So this differential equations, I think you need some help, no?
Hmm. Yes, sir.
And area and integrals, you did not do, no?
Done.
This is done.
I I did it, sir. Board level, everything done.
Ah, okay, okay. Good, good. So
Learned area derivation also.
okay, okay. So this, so then this also you're done. So this
Hmm.
also, I think at least board level now, I think you can finish, except that
Hmm.
reduction formulas. Okay.
Reduction and then definite integrals and partial.
This one partial fractions you have to do this one, and
Hmm.
then definite integral and application of integrals is
Indef-
actually
sir,
definite integral. What man?
sir, I was saying indefinite integrals.
Indefinite in that this is all indefinite integrals only, no? What else indefinite you are talking?
Oh, the first part, entire thing is indefinite itself.
This is called indefinite. This
Hmm.
entire
Fine.
part till this part till 7.6 is called indefinite integration
Got it.
because you are adding
Yeah,
some
then.
constants. Plus C you are putting, no? Whenever
Ha ha.
you are putting limits A to B, then that becomes definite because you know what exactly is the value. Because otherwise you
Okay.
put some constant because you don't know
Hmm.
what exactly is the value. That's why it is indefinite. Okay.
Got it. Got it, sir.
Okay.
Then
So
done. Most of
most of it is done, I think. Okay, then I think for boards you are in a decent shape only now.
Then, sir, in part one also, I'll tell what I completed. Or
Oh, okay, okay. Let me just
sir, here only it is there. No, sir. If you scroll up,
1 second, 1 second. Where is this? This is in part.
part one, sir. Part
Oh,
one
okay, okay.
contents.
Right, right. Part one, tell me.
Sir, relations and functions done.
Done, very good.
Then inverse trigonometric functions also done.
Very good, excellent.
Matrices, determinants both done.
Both done, very good.
Continuity and differentiability. Maybe one last time I need to revise again, sir.
Ah, ah.
Application of derivatives also done.
It is also done. So very good. No, part one is also mostly done then.
Hmm.
Then you are, it looks like you are on track only then. At least from board's perspective, you should get 100 on 100. What, how much is the exam for?
Exam is for 80 marks.
Oh, okay. 80 by 80, you should be able to get then. Okay. Just
Hmm.
do one kind of thorough revision. Okay. Then we have to cover this piece. What this differential equations and some pieces, small pieces here. Okay.
Hmm. Yes, sir.
Then you will be done. Okay, ma?
Yes, sir.
Cool then. Good, good.
Hmm.
Ah, where are we? Okay. Good. I think you are doing well only. Now,
Yes, sir.
after this, okay. No. Are you doing this one also? K set questions now? That's Karnataka set, or you are doing?
Uh, Boards only, sir.
Okay.
Mostly I'm doing previous year papers and all.
That you do because KSET and board more or less are of the same this
Same
thing,
level.
same level only. So if you are thorough with your NCERT textbook and all, that is more than enough for KSET also. Okay.
Hmm.
Okay.
Okay, sir.
So once first you finish off the boards, after that
Hmm.
anyway for PVQs, KSET we have a lot of other PVQs also. Okay, lot of
Yes,
other
sir.
exams, PVQs are also there. So for now, just to finish up this all the basic things. Okay, then you can get
Hmm.
into mains PVQs also. Mains PVQs will be slightly, or in fact, they will be the long answer questions in our board. Whatever you will get, no. Mains
Hmm.
PVQs would be slightly like that.
So, sir, after March 20th, like once my board exams end, you will start with mains PVQs.
Okay, ma'am. Then we'll start with mains PVQs. Till then, you focus on this. All the basics should be covered by then, so that our mains
Oh.
PVQs will become easy. We don't need to,
Hmm.
we should not be discussing concepts during mains PVQs. We should be just doing problems. Okay.
Okay, okay, sir.
Okay. And we have to once do your first year syllabus also. Let's not do it now. Okay.
Hmm.
You focus on boards. When are your exams? March or
March 3rd to March 20th.
March 20th. Okay. Meanwhile, then ideally, right now, then if you are comfortable here, you focus on other subjects also. Okay.
Yes, sir.
Okay. But this one you
Because
should.
in between exams, not much gap is there for us.
That's what. So let's don't worry about this mains PVQs and all because you have other
Hmm.
exams also to prepare. No. Okay.
Yes, sir.
So right now
And
we'll.
sir,
Uh,
after board exams end,
uh,
I'll have almost 1 month time for KSET.
KSET is when towards April end.
Sir, actually, here in Karnataka, KSET and Comet K both are there. So, KSET is written by the people who have lived in Karnataka for 7 plus years. So, since I can't write KSET, I'm writing Comet K, which is similar to KSET.
Okay. So the admission is for whom? For what colleges?
All colleges in Karnataka.
Okay. 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 Then are you writing for other entrance tests also like Andhra and Telangana?
I'm
These.
writing AP and TS MSET also, sir.
Right. Right. You do that also. Okay, but
And
I
then
think you
I'm
are local for then
writing.
AP
Yes, sir, sir.
Karnataka for where exactly you are counted as home then? Is it Telangana?
My hometown?
No. See, for you are not counted as local fellow for Karnataka, no? But somewhere you
Ah,
must be counted. Which is that state that will count you as home?
Telangana.
That should be Telangana. Then this T set you have to write then.
TSM.
Telangana, Telangana M
Uh-huh.
set, right?
Yes, sir.
Okay. That I think you will have little more time towards April end or
Sir, I don't know. I need some guidance for MSET, sir. I had this doubt.
uh, uh.
So what I wanted to ask was, how is there any eligibility for like if you live these many years in that state, then only you can write, or if you pass
No,
10
no,
plus?
writing anyone can do, but whoever have stayed, no, like in Karnataka only, they will have the seats are reserved for the local people. It is
So,
like that.
sir,
Uh,
I lived in Hyderabad for only 8 years.
uh, uh, uh,
We had a own house before over there, but not anymore.
uh.
So, are we considered as local residents or no?
That we have to see it again. Okay, so
Because, sir, even 10th grade I didn't
no,
study
I
over
think
there.
continuous one. I don't know exactly what is the exact rule. I will find out and tell you. Okay.
Hmm.
But okay, ideally, because you have lived for 7 plus years in that state, you should be considered ideally. Okay.
Okay.
But
And even I took Telugu as
okay, I'm
I
set. Local candidate eligibility. Okay, let's see right now. Local candidate must be permanent and meet other. Okay, OCIPOA something something. Think we have to read this in slightly more detail.
Yes, sir.
Okay, I think they have to write in this board. That's what they are saying, I think.
Oh, I should have passed 12th from their board.
It's not material, it's not important how long you stayed. I think passing from that board is a requirement, I think.
Sir, even for APM set,
APM set, okay. Let's see. APM set. You must be on the Pradesh, Nagar. But you can write without for the local people. So a lot of people write from outside
so
also.
even if I get rank and marks, even if I get rank and marks, theirs will be more considered, you're telling.
Ah, right, right. They will have more preference. Exactly. The local will be given more preference. Exactly.
Okay. Same here also, no, sir.
Same in Karnataka also, no? But AP Telangana, at least they are
Sir,
giving, if they are doing the board in AP Telangana, they are considering that. No, but in Karnataka, they are not considering. That is strange.
like, sir, KCET even I can write, sir, no problem in it.
Hmm.
But same thing, they won't consider.
Ah, they will not give you weightage, no? The local weightage they will not give.
Yeah, there
So,
is even some eligibility for Hyderabad candidates, but that comes under whatever lies between Karnataka, like Bangalore and Hyderabad, whatever states come in between, like
oh, okay.
towns and villages,
Ah,
for
ah, ah.
those people.
Oh, okay, okay. So Bangalore is not counted there.
Bangalore is not counted, Hyderabad is not counted, everything
Oh,
between is counted.
oh, ho, ho, ho.
It's called Kalyanakatta Hyderabad candidate eligibility.
Ah, okay, okay, okay. No, cool. Don't worry. These things, if things are not in our hand, there's no point worrying. Right now. So whatever is in our hands.
So, sir, yeah, I'm writing Comet case, sir. It is like same thing as KSET
Ah,
itself, but for students like us.
good, good. So write as many exams as you can. Bits anyway you will write, right? Bits and
I'm
all those
writing BITSAT, I'm writing VIT, I'm
VAT you will
writing
write.
Manipal University,
Right,
Anna
right.
University.
Right, right. Write as many exams as you want. Okay. Because the preparation is same, let's put our best effort. And at least the bits and all, you don't have any this kind of reservation. Right.
So,
Reason.
sir, can you talk to my dad about this TSM set and APM set, saying that this is the eligibility criteria? Because I told it long back, but then he didn't listen. He was
Okay.
like, everyone can come and write. He's not getting that part of
Oh,
it.
okay, okay. So
So I
he,
guess if you talk with
okay,
him,
okay. He's saying no need to write, huh?
no, no, he's saying you can write it, you will get it also. But
Oh, okay,
my
okay.
problem is I won't get. That's the thing. Even if I
Oh,
write,
okay, okay. So that local criteria is not there, but doesn't matter. Let's put our effort. No, let's try to write. There will be, so who knows? The pool might be smaller for outside people.
I will write it, sir. I'm not telling I won't write it. I
Uh-huh.
just want you to tell my dad that it is not something which is pakka guarantee if I get off
Okay,
marks
okay.
in some way.
That I will tell you.
Uh-huh.
That I will tell him because it is you are not counted as a local candidate. No. That let
Hmm.
me read this again. Probably this is a different side. No, let me read the official document also. Okay.
Okay, okay, sir.
Then we'll see what exactly is this thing.
Hmm.
Okay, then that will help. Okay. But anyway, if it is not in our hands, we should not worry. Whatever is in our hands, we'll do that best.
He's making me write TSM set because he wants me to join in Geetam
Geetan,
if I get.
Geetan is in Andhra, no?
Geetam is also there in Hyderabad branch, sir.
Okay,
It's there.
they would have put there also. Okay, okay.
Hmm.
No, no, no. Then you try. Why Geetam?